In this video I'm going to show you the planet generation system that I've been working on for the last few months. This system allows you to spawn a planet with a random terrain in a visualised solar system and then edit the properties of the terrain and the planet coloration to your liking. First off, there is a quick montage to show the system being used, and then I will get into how the terrain works, and then I will go into how the custom editor window works for the planet settings. Now let's get into how this system works. The first step in the system was to create a basic sphere planet. This could be achieved with Unity's basic sphere shape, however instead the choice was made to use a sphere made up of 6 curved faces, essentially making the sphere from inflating a cube. This was done so that the detail is even across the planet as the triangles get smaller towards the poles with Unity's own sphere object. The next step was to modify the planet's shape using noise. As I wanted a smooth generation of land masses and not just patchy bits of land that don't blend, a type of coherent noise was needed. Coherent noise generation is a type of noise generation where the values are interpolated between each other to create a smooth noise distribution rather than chunky distribution. To create this coherent noise, the simplex Perlin noise algorithm was used. The initial implementation of this noise creates a planet that looks like this. However, I want something that looks more planet-like, so a minimum value is applied. This makes the noise essentially retract into the planet so that we get land masses and not a deformed sphere. The noise is generated here in the noise filter script, where it uses an open source version of the simplex Perlin noise algorithm to randomly generate the noise for this instance. The noise made here is then used to construct the mesh and terrain face script using the different evaluated heights that the noise has generated. However, this noise alone doesn't look very planet-like with its terrain. I wanted more realistic terrain, so I needed it to have ridges to it. To achieve this, I needed to get the absolute value for the elevation and invert it, to create this sort of ridge-like pattern like this. Adding an additional layer of noise, but with the ridge settings, creates a much more planet-like terrain distribution around the planet like this. Next up, I thought it needed some colour. So I implemented a shader that evaluates the height of the terrain and applies the gradient shader based on the height to give it a more planet-like look to it. So the core colour of the planet is the blue ocean, and as it gets higher it goes from the sandy beaches to green land to the muddy and grey mountains. This was just implemented using Unity's shader graph and the universal render pipeline. Applying this shader gives me a nice colour to the terrain that looks more Earth-like to it, but it can be any colour you choose it to be. After I had somewhat of a planet made with the colour and terrain, I figured it was a good point to implement it into a visualisation of a solar system. So I started by creating a central star that the planets would orbit within the Unity scene. And then I created a script that would tell the planets to rotate around that star object when the program is running. However, planets don't just orbit around a star, they also spin on their axis. So I gave the planets a function to constantly spin when the program is running. Now that the orbit system was in place, I wanted to make it more visually clear to the user where the planet was going to travel, so I implemented a line render that draws the orbit path of the planet. I achieved this by creating a physics scene that runs alongside the normal scene, but at an accelerated pace. A duplicate version of the planet is put in the scene, and the path is rapidly progressed and each position is plotted onto the line render, where it is then drawn to show the user. This all happens in a matter of a few seconds when the planet is created. Now I had the base planets made with noise, and they are implemented into a solar system visualization, I went back to developing the planets more. This time creating the ability to have different biomes on the planet, so that you can have different climates represented. To do this, a gradient was created for each biome so that the biome can have a different land colour to the rest, rather than it all using the same basic gradient. I also added the ability to apply a colour tint to the biome, as this can be used to help represent climate temperature just with a tint of colour rather than completely reworking the gradient colours. A value for the start height of the biome is then also added so that you can choose where on the planet it starts and ends. Next up, I wanted to make it so the planets can be spawned in at the click of a button, and each planet would be different. To achieve this, I created a spawn planet script. In here, a prefab of the terrain planet is spawned, and its noise and colour settings are randomised so that no two planets are the same. The tint colour for each planet is calculated based on its distance from the star, so the planets that are closer to the star have a red tint, and the planets further away have an icy blue tint. This is to show that the star is a heat source and that is affecting the planet's temperature. Now that system is in place, it's time to implement the final features. The first of the final features is the ability to have the camera focus on a planet that you click on. This is very simple as it's a ray being cast from the mouse position into the scene, and if it hits a planet then the camera will look at the planet and the field of view will be decreased to zoom in on it. The feature to pause the orbits was also implemented to make it easier to click on a planet and make it less disorienting to look at when the camera is zoomed in. The last feature to add is the custom editor window, to make it easier for users to select a planet and modify its terrain and colour settings. I'm not going to go fully into depth as to how the custom editor works as it's quite self-explanatory, but here's the code for it. It just simply accesses the settings stored on the planet for its noise generation and colour generation, and gives the user an easy to use field to change that setting. Now we've created all the features, we can take a closer look into how the system works in action. First of all is the resolution. This determines how detailed the planet's sphere is, so a higher value will give us more detail for everything else in the system. Next up, we can change which face of the sphere is rendered. The radius option allows us to change the size of the planet. Now the basic settings are covered, we can get into the noise settings. The first noise layer is used as the basis for the other layers and is made of simple noise. The first setting we can modify is the strength. This determines how strong the change in terrain is. A lower value gives a terrain that produces a lot less than a higher value. Then there is the number of layers. This is the amount of layers of noise that is used for the noise layer. So a higher value will mean the noise is produced more times and the values are interpolated together, so more layers will give more detailed random terrain. The base roughness is the setting that determines how smooth the base value of the terrain will be. A higher value will create more rocky and bumpy terrain for the base. The roughness setting is the bumpiness that is randomly added around the terrain, creating more of a mountainous effect. The persistence is how much the amplitude changes around the planet. So a higher percentage will mean you get more mountains and peaks from the layer, but a lower value means you'll only get the smaller amplitude changes that are applied. The centre is the point the terrain is generating at. This just moves the terrain around the planet so you can have the land masses appear at different areas of the planet. The same settings are used throughout each layer and do the same thing but for that layer. The rigid noise layers, however, have a weight multiplier. This determines how much of an effect the rigid noise will have on the planet, so a higher value means the layer has more influence on the planet. There is also the ability to add more noise layers to the planet to create more detailed effects. And then there is also the ability to remove a noise layer if you do not want it. Then we can get into the colour settings. In here we can change the colour settings for the biome, for example the tint value. I can change this to another colour and you can see it change the tint of that biome. The start height value determines where the biome begins on the planet's surface. A value of 0 is at the bottom. You can also change the colours in the gradient of a biome. So for example, I could give this biome a red to pink gradient. Reducing the tint value allows you to see the colour more clearly, as there is no overlaying colour. The blend percent determines how well the biomes mix together. A higher value will give a smoother transition and lower value will make it seem more like it's just strips of colour. Like with the noise, we can also add and remove biomes. Finally, you can change the colour of the ocean. So for example, if I wanted, I could turn this ocean into a blood red gradient. And there we have it, a finished planet generation system ready for it to be used to make your own planets, and turn them into prefabs to be used for anything you want.